As I mentioned before we started this, not just doing the special case stuff today, but that's where we're going to start. So, couple things to mention. If you weren't here yesterday, you might want to get some of this stuff. And if you were, a couple of things to mention here as well. So these first 8 problems here, I'm going to do a couple of them. I'm not going to go crazy with this. Actually, move down a little bit. I'm going to play with these too. So when we're trying to figure out this stuff, the pattern we're going to run is really simple and really straightforward. If you see a 2-termer and if they are both perfect squares, well, how would I know that? This purple list that I've jotted at the top of my 11-6 notes might be helpful because you're going to see both numbers here. I am a fan of then taking each piece of that and saying, okay, what do I square, or what's the square root of that number? If I jotted this down yesterday in my 11-6 notes, I'm going to have it right there. And then I'm going to do the same thing with my 16. Square root of 16 is 4. Once I've got those, that was actually the hard part. Because that 5x, whatever I got for the first term, goes first in both sets of parentheses. Whatever I broke down my second term, that goes second in each one. One gets a plus, one gets a minus, and we're done. That's it. Nothing else to do, nothing else to finish, nothing else to check. Those 2 values, plug them in with a plus minus, we're on our way. And so if sometime you just have a variable, or if you just have a 1, that's okay. We can still do that. And so the other one, actually, I'm going to do 7 instead of 8, because I want to talk about that whole thing when we get into just a variable. Now here, you're like, Hardy, there's no number there. I guess I could put a 1, but I don't really need it, because anything to get a variable squared is just the variable. So x to get x squared. I square 3 to get 9. Don't forget the y that's there. If there's a variable, I got to have the variable with. And it's the same pattern. There's what goes first in each set. There's what goes second in each set. And just a plus and just a minus, just like it says right there. So yes, you can have variables in both spots. You can have it just the first spot. You can have it just the second spot. It kind of just depends on the problem itself. So the squares, nothing too bad. Then where the heck did this stuff come from? Okay, radicals are showing back up. That was like first 2 weeks of quarter number 3. So here again is the good news here. Okay, all we're doing is we're going to treat the radical like it's x, like it's a variable. You're like, okay, what? Huh? So, for instance, let's just say that this was negative 3x minus x, or minus 1x, because I'm just treating that radical like it's a variable. Negative 3x minus 1x would be negative 4x. So if I owe my friend $3 and I borrow another $1, I owe him 4. It's the same thing here. The radical stays the same, just like here the x stays the same. Negative 3 minus 1 is negative 4. I'm done. Keep it simple. Treat it like you would x. As long as these are the same, you just add or subtract the numbers that are in front of them and you're done. So don't make life complex. Hardy, why would you put that here in the middle of nowhere? I don't know. Might be showing up on the quiz. Maybe. Trying to give you like a big old warning on what's coming. Just saying. Oh dear. Oh dear. What happens, if the radicals aren't the same? Can I still put them together? No. We're going to have to go back. Yes, old school. We got to break these down. This is actually going to come in handy for me again. Okay, my perfect purples here. Now I've got to go back and I've got to see, do I have my multiplication chart here? I got to grab it. There it is. Like, what do you need that for? Okay, because here I kind of look and I'm like, okay, 5 is 5 and 1. That's not going to break down. So I'm just going to rewrite that. But then I get here and I look at 20. If, besides 1, if I look at the other numbers in the 20 box, are there any perfect squares in there? 4's in there. So 4 goes with 5. So here's how this works. We're going to take the 20. We're going to break it up into 4 and 5. And that perfect square, the 4, square root of 4 is 2. Yes, so here, that 2 that was here originally is still there, but now my square root of 20 is 2 times that square root of 5, because I didn't get to break down the 5. 5's not in the perfect list. It doesn't get to break down. But now I'm starting to see a crack here, a glimmer of hope that I can simplify this more, because these can be multiplied together. They're not under the radical. And all of a sudden, it's like the first problem that we did. Because now, these are the same variable. I treat them like I would x. This is like 3x minus 4x, which would be negative 1x. But this isn't x, this is the square root of 5. So if they're not the same, you're going to have to go in and break them apart. Maybe just, sometimes maybe you can just look at these and figure out what number. Otherwise, use your chart. It's a way for us to combine old and new. It's kind of nice. Now, some of these get a little more complex. This is a little crazy. So let's look at this. You're like, 240, that's not even on my chart, Hardy. Okay, here's what we're going to do. Not on the chart, I agree. So, I'm going to grab my handy-dandy calculator. Here's my perfect squares. I need one of them to go in here. If I don't know, if I have no idea what goes in, I'm going to start with the biggest one. And I'm going to start dividing all these perfect squares in until I run into one that goes in nice. Now, it may take me it may not take me long. Okay. So I divided in 49. So I got 49, I got 5 out. So that's my method to figure out where the breakdown is. So once I get there, the square root of 49 is 7. It gets out of radical jail. There it is. 5, not perfect. You do not get out. 7, square root of 5. I'm done. If it's a small enough number that you can find it on your chart, take advantage of the chart. Find the perfect square that's one of your factors. But that's all we're kind of doing there. So for instance, let's play with one more of these. Let's play with 19. So 72, that's actually on my chart. So let's see how this would work. Ooh, look at all those numbers in that table. Looking for the biggest perfect square, not just the first one I see. So like I see 4. Okay, but if I keep going, let's make sure. Oh, 9. Oh, wait, keep going. Are there any? Oh, there's the biggest one. 36 and 2. Got to get the biggest one. So the square root of 36 is 6. 2, you are not in the perfect list. Nope, you don't get to break down. Off and running. Okay. So that's kind of our radical. We get to use our tools that we've got, and it works pretty well. So now, if I got anything left that could help me here on this, let's see. We might have to use our brain on this. Oh, wait. Maybe. Let's see here. Simplify. Your answer should contain only positive exponents. Ruh-roh. Okay. Couple of things to remind us. Let's see. If we got room on our notes, if we're forgetting some of this, where I could write this. Well, I got a couple of spots. I'm going to put things here, though. So here, depending on the problem, we're still going to multiply bigs, just like we have been. So 4 times 3 is 12, okay. Oh, dear. Multiplying with exponents. What do you do to the exponents? Multiply them, add them, subtract them. What do I do with them? Oh, the silence. Okay, so when we're multiplying, we're going to add the exponents, even if they're negative. 3 plus negative 2 is positive 1. Okay, that's cool. Y's, same thing. There's my Y's. If colors are helpful to make things jump out, grab some colors. I got plenty. 4 plus 4 is 8. Everything's put together. Happy, happy. Reminder on one thing as well. If you see a variable and it doesn't have an exponent, make sure you remember there's a 1. That's all we got to do. Okay? If we go power to power, oh, let's change colors here. And again, I'm just kind of jotting this stuff down here. I put the parentheses around it because it kind of reminds me there's an exponent out there, and I'm going to see parentheses here. Since I'm kind of trying to give you some hints here, might be something to put on the notes, just saying. So here, whether it's a number or whether it's a variable, you're multiplying the exponents together. So 1 times 3 would be 3 to the third. 1 times 3 would be x to the third. 1 times 3 would be y to the third. We don't want to leave the number part, though, because we can actually figure that out. If 3 to the third, not 3 times 3, you're kind of thinking, yeah, I'm not sure on that. There's my exponent button, right above the divide. 27. X to the third, y to the third. Oop, there it is. We get that in there. Distribute that through. One more rule. The bigs, we still do what we see. But here, if we're going to divide, we're going to subtract the exponents. Big minus little. Answer with the bigger exponent. So we'll break this down here in a second. I know that's a lot to write down, but division has a lot of interesting stuff that's going on. So we're actually going to do 26 because there's a twist with that we kind of need to talk about. We might actually chat both of these. So if we do 25 first, let's chat this through. You divide the bigs. 2 divided by negative 2, negative 1. Subtract the exponents. Okay, 4 minus 1 is 3. The bigger exponent is on top. So my answer goes where the bigger exponent is, which would be on top of my fraction. If that 4 would have been down here, I'd have put the m to the third down at the bottom, down in the denominator. What's that? Yeah, so what's 2 minus 2? This is not a trick question. 2 minus 2? 0. So the ends just wipe out. Okay, if you get a 0 power, that's just gone. So that's the answer. That's all I got. That's all I got left. And so as we do these, I am going to make a suggestion on the next one, though. So that 4 is on its own, so we're just going to leave that alone. Negative exponents. Okay, I hate trying to do the subtraction with negative exponents. It's a pain in the butt. So remember, if you have a negative exponent, if you flip it to the other side, it makes it become positive. Now, do I need to flip these? No. They're positive already. They're happy where they're at. They don't need a behavior adjustment here for their negative attitude, just these two. And so now you're like, wait a minute, it's not divide anymore. These are all on the same level. Now we're back to multiplying where we add the exponents. So I look, I'm like, okay, so there's my x's, add them up. There's my y's, add them up. What about the 4? Do I need to flip the 4? No, the 4 is fine. It's perfectly positive. It can just stay where it's at. Don't flip it. Just leave it be. Let it do its thing. And so this is kind of warming us up. This is showing back up again tomorrow. And it's going to show up again on the quiz. So, reminder of your best options. Number 1, finish this. Number 2 option, either complete some of the stuff behind this if you haven't done it yet, or update your notes that I'm going to pop up from Classroom here in a moment. Or if you've got quizzes or tests or things that you never finished or started before, let's get those going. Because again, Santa Claus don't come in June. That part of things is gone. So if you